Download this code from codegive.com, link in the description below. Dynamic NAT, masquerade, in routeros, a comprehensive tutorial. Dynamic Network Address Translation, NAT, often referred to as masquerade in routeros, is a crucial feature that allows devices on a private network, like your home or office network, to access the Internet using a single public IP address assigned to your routeros router. It works by translating the private IP addresses of your internal devices to the public IP address of the router when they send traffic to the Internet and then mapping the return traffic back to the correct internal device. This effectively hides your internal network structure from the outside world and conserves public IP addresses. This tutorial will cover the following. 1. Understanding dynamic NAT, masquerade. 2. Why use dynamic NAT? 3. How dynamic NAT, masquerade, works. 4. Setting up dynamic NAT in routeros, with code examples. Basic masquerade rule. Masquerade based on source network. Masquerade based on interface. Masquerade with port forwarding, DNAT. Masquerade with specific source ports. Masquerade with connection tracking helper. 5. Important considerations and troubleshooting. 6. Security implications of dynamic NAT. 7. Conclusion. 1. Understanding dynamic NAT, masquerade. Dynamic NAT is a core function of most routers. It's a type of NAT that dynamically assigns a public IP address to a private network when devices on the private network need to communicate with the Internet. This contrasts with static NAT, where a specific private IP address is permanently mapped to a specific public IP address. In routeros, dynamic NAT is primarily achieved using the masquerade action within the firewall's NAT, network address translation, chain. The term masquerade perfectly describes the process. The internal devices are masked behind the router's public IP. 2. Why use dynamic NAT? IP address conservation. The biggest benefit is the ability to share a single public IP address among multiple devices on a private network. With the scarcity of IPv4 addresses, this is essential for most home and small business networks. Security. Dynamic NAT adds a layer of security by hiding the internal IP addresses and network topology from the Internet. External devices cannot directly initiate connections to devices behind the NAT without specific port forwarding rules. Simplified network management. You only need to manage a single public IP address for your entire network. This simplifies configuration and troubleshooting. NAT traversal. To some extent, while not a complete solution, dynamic NAT allows most applications to function correctly through the router without complex configuration. 3. How dynamic NAT, masquerade, works. Let's illustrate the process with an example. One internal device initiates a connection. A computer with a private IP address of 192.168.1.10 wants to access the Google website, public IP address. 2. Packet reaches the router. The computer sends a packet with the following information. Source IP, 192.168.1.10. Destination IP, Google's IP address. Source port, a random port number, example 50,000. Destination port, 80, HTTP, or 443, HTTPS. 3. Router applies masquerade. The router intercepts this packet and performs the following NAT operation. It changes the source IP to its own public IP address, example 203.0.113.1. Asterisk it changes the source port to a new, unused port number, example 50001. Asterisk it creates a NAT table entry that maps the original internal IP address, 192.168.1.10, and port, 50,000, to the new external IP address, 203.0.113.1, and port, 50,001. For packets sent to the Internet asterisk the router sends the modified packet to the Internet. Asterisk source IP, 203.0.113.1. Asterisk destination IP, Google's IP address. Asterisk source port, 50,001. Asterisk destination port, 80, HTTP, or 443, HTTPS. 5. Google responds asterisk Google sends the response packet back to the router's public IP address and the port number used in the request. Asterisk source IP, Google's IP address. Asterisk destination IP, 203.0.113.1. Asterisk source port, 80, HTTP, or 443, HTTPS. Asterisk destination port, 50,001. 6. Router reverses the NAT asterisk the router consults its NAT table and finds the entry matching the destination IP and port of the response packet. It reverses the NAT operation. Asterisk it changes the destination IP back to the original internal IP address, 192.168.1.10. Asterisk it changes the destination port back to the original internal port number, 50,000. 7. Packet delivered to internal device asterisk the router forwards the modified packet to the internal device. Asterisk source IP, Google's IP address. Asterisk destination IP, 192.168.1.10. Asterisk source port, 80, HTTP, or 443, HTTPS. Asterisk destination port, 50,000. The internal device receives the response from Google as if it had communicated directly, without being aware of the NAT translation. 4. Setting up dynamic NAT in routeros, with code examples. Open your routeros terminal, either via Winbox, Webfig, or SSH, to configure the firewall rules. Remember that the order of the rules in the firewall matters. Typically, you want to allow established connections first, then apply NAT rules. Asterisk important notes about interface naming asterisk throughout these examples, replace placeholders like WAN_interface with the actual name of your internet-facing interface. You can find this in Winbox under Interfaces. Common names include either one, PPPoE-out1, ULAN1, or a custom bridge interface dedicated for WAN. Asterisk private network address asterisk replace private_network in examples with your private network address, example 192.168.1.0/24, 10.0.0.0/24, 172.16.0.0/24. Ensure it corresponds to your actual internal network range. 4.1. Basic masquerade rule, most common. This is the most straightforward and commonly used dynamic NAT configuration. It masquerades all traffic originating from your private network that is destined for the Internet. Explanation asterisk. */IP firewall NAT, navigates to the NAT firewall rules section. *add chain equals SRC-NAT, adds a new rule to the SRC-NAT, source NAT, chain. This chain handles outbound NAT. *action equals masquerade, specifies the masquerade action, which performs dynamic NAT. *out interface equals WAN_interface, specifies the interface that the traffic must exit to be subject to masquerading. This is crucial. Replace WAN underscore interface with your actual WAN interface. Asterisk src address equals private underscore network, specifies the source address range that needs to be masqueraded. Replace private underscore network with your internal network address. For example, src address equals 192.168.1.0/24. Example asterisk if your WAN interface is Ether 1 and your private network is 192.168.1.0/24. 4.2. Masquerade based on source network, multiple private networks. If you have multiple private networks, you can create separate masquerade rules for each. Explanation asterisk. This creates two separate masquerade rules, one for 192.168.1.0/24 and another for 10.0.0.0/24, both using the same WAN underscore interface. 4.3. Masquerade based on interface, less common, usually WAN interface is sufficient. While using the out interface is generally the preferred method, you can also masquerade based on the interface that traffic enters the router on. This is less common and often less accurate, but could be useful in specific, complex scenarios. Explanation asterisk. Asterisk in interface equals LAN underscore interface. This specifies that the rule only applies to traffic entering the router on the specified LAN interface. Replace LAN underscore interface with the actual name of your internal LAN interface, example Ether2, Bridge 1. Asterisk important asterisk using in interface alone without src address is generally not recommended, as it can potentially lead to unintended masquerading of traffic. Always combine it with a src address. Example asterisk if your LAN interface is Ether2 and your private network is 192.168.1.0/24. 4.4. Masquerade with port forwarding, DNAT, connection tracking helper, important for some protocols. Port forwarding, also known as destination NAT, DNAT, allows external devices to initiate connections to specific internal devices behind the NAT. Masquerade and port forwarding often work together. Example asterisk forward port 80, HTTP, from the WAN interface to an internal web server at 192.168.1.10. Explanation asterisk. Asterisk DNAT rule, first rule. Asterisk chain equals DSTNAT, adds a rule to the DSTNAT, destination NAT, chain. This chain handles inbound NAT. Asterisk action equals DSTNAT, specifies the DSTNAT action, which performs port forwarding. Asterisk to addresses equals 192.168.1.10, the internal IP address where the traffic will be forwarded. Asterisk to ports equals 80, the internal port where the traffic will be forwarded. Asterisk protocol equals TCP, the protocol, TCP in this case. Asterisk DST port equals 80, the external port that will be forwarded. Asterisk in interface equals WAN underscore interface, the interface where the incoming connection is expected. Asterisk masquerade rule. Second rule. The standard masquerade rule ensures that traffic originating from the internal web server, 192.168.1.10, can still access the Internet. 4.5. Masquerade with specific source ports, uncommon, for specific applications. In rare cases, you might need to masquerade traffic only when it originates from a specific source port. This is generally not recommended unless you have a very specific reason. Explanation asterisk. Asterisk src port equals 5000-5010, this only masquerades traffic originating from the internal network that uses source ports between 5000 and 5010. 4.6. Masquerade with connection tracking helper, important for some protocols, FTP, SIP, etc. Some protocols, like FTP and SIP, use multiple connections and embedded IP addresses within the data stream. These protocols require a connection tracking helper to function correctly through NAT. Explanation asterisk. Asterisk connection tracking equals enabled, tells the firewall to actively track connections. This is usually enabled by default, but it's a good practice to add it when dealing with protocols that have issues with NAT. This can slightly increase the router's CPU usage. */IP firewall service port enables the connection tracking helpers for specific protocols like FTP and SIP. You may need to experiment with other protocols depending on your needs. Some common helper names include FTP, SIP, TFTP. Important notes about connection tracking helpers *** performance impact * enabling connection tracking helpers can increase the router's CPU usage, especially with high traffic volumes. Only enable them for protocols that actually require them. Potential security risks incorrectly configured connection tracking helpers can sometimes introduce security vulnerabilities. Carefully research the specific helper you are enabling. Testing after enabling the service port, thoroughly test the application or protocol to ensure it's working correctly through NAT. 5. Important considerations and troubleshooting. Firewall rule order the order of rules in the firewall matters. Place your masquerade rules after any rules that allow established/related connections, example allowing incoming responses to previously initiated connections. Typically, you want to allow established/related connections first, then apply masquerade rules. Incorrect interface the most common mistake is specifying the wrong out interface. Double check that it's actually your internet-facing interface. Incorrect source address make sure the SRC address matches your internal network. MTU, maximum transmission unit. If you're experiencing connectivity issues, especially with large packets, check the MTU settings on your router and your client devices. A common issue is an MTU that's too large, leading to fragmentation problems. Double NAT if you have multiple routers performing NAT, example a router provided by your ISP and your own routeros router, you can experience double NAT issues, which can cause problems with certain applications. If possible, put your ISP provided router in bridge mode to disable its NAT functionality. Logging enable logging for your firewall rules to help diagnose problems. You can add log equals yes to your NAT rules to log when a packet is matched by the rule. However, be mindful of the potential impact on router performance. Connection tracking table full * in very high traffic environments, the connection tracking table can fill up, leading to connection problems. You can adjust the connection tracking settings in /IP firewall connection tracking, but be careful, as incorrect settings can negatively impact performance or security. Review your rules use /IP firewall NAT print to review your rules and ensure they match what you expect. Pay special attention to the interfaces and source/destination addresses. Test always test your NAT configuration after making changes. Use tools like Ping, Traceroute, and web browsers to verify that devices on your internal network can access the internet and that port forwarding is working correctly. 6. Security implications of dynamic NAT. Increased security dynamic NAT provides a basic level of security by hiding internal IP addresses from the internet. This makes it more difficult for attackers to directly target devices on your internal network. Asterisk not a firewall replacement. Asterisk dynamic NAT is not a substitute for a proper firewall. It only hides internal IP addresses. You still need to configure firewall rules to control which traffic is allowed in and out of your network. For example, you should only open the ports you need to use, and block all other incoming traffic. Asterisk port forwarding risks. Asterisk opening ports with port forwarding can create security vulnerabilities if the service you are forwarding to is not properly secured. Keep the software up to date and use strong passwords. Asterisk stateful inspection. Asterisk routeros firewalls perform stateful packet inspection, which means they track the state of connections and only allow return traffic for established connections. This adds another layer of security beyond basic NAT. Asterisk regular audits. Asterisk regularly review your firewall rules and NAT configuration to ensure they are still appropriate and secure. 7. Conclusion. Dynamic NAT, masquerade, is a fundamental feature of routeros that enables multiple devices on a private network to share a single public IP address and provides a basic level of security by hiding internal network details. By understanding how dynamic NAT works and carefully configuring your firewall rules, you can create a secure and efficient network environment. Remember to always test your configuration thoroughly and stay up to date with security best practices. Using the code examples and explanations in this tutorial as a starting point, you can customize your routeros configuration to meet the specific needs of your network. Good luck.